yesterday to go through and do some of the review portion. So here it says a mixed radical, which you talked about in grade 10. Mixed radical is the little number above the square root is an index. If there is no number there, it's the index, but it's still a number. There's no number there. What's the number? 2, because it's a square root, correct? If it was like the square root symbol, that would actually be an index of 2. The number in front is coefficient. That's the radical sign. And what's underneath the radical is a radicand. You were taught that last year. Like radicals will all have the same base and radicand and index. So if it's a like radical, they would have the same value under the square root symbol. So the same radicand, like a square root of 3 or square root of 5. So you know we can only get like terms when we have the same thing. So when it's like 3x plus 4x, I can put those together, right? And 8 plus 7, I can put those together. And 6x squared minus 2x squared, I can put those together because those are like terms, correct? Same thing happens with a radical. You have to have the same thing underneath the radical in order to put them together. So if I had like 2 root 3 plus 4 root 3, I could put them together, just like 2x plus 4x. It's the same thing. But you need to have the same thing under the radical. A radical in simplest form is a radical term where the radicand does not contain a fraction, the radicand does not contain a factor that can be removed, and the denominator does not contain a radical. So we're going to deal with all of that this unit. There are restrictions on variables in the radicand of a radical with an even index. Specifically, the radicand with an even index must always be positive. So for example, if I had square root 10, that's fine, right? I can get an answer. What about square root negative 10? Can I get an answer? Can you square root a negative number? No, you can't. So if I instead gave you square root x instead of a number, because we're going to have variables this year, not just numbers. If I give you square root x, what can you tell me about what's underneath that radical? Yeah. No. What has to be underneath the radical? Yeah. It has to be positive or equal to 0. So whatever's underneath this baby here has to be positive or equal to 0. So what could I say then about x if I just had an x under here? X has to be greater than or equal to 0. So whenever we have variables under our radical, so variables in our radicand, we have to state what our x value can't be, or what it has to be greater than, or what it has to be equal to. Because if it was anything else, you'd have a negative underneath, which we can't do. So yesterday I told you guys to do this. Express each entire radical as equivalent mixed radical in simplest form, because we did this for one day, part of one day at the very beginning of the year. It's also you did in grade 10, so it's just a review. So what can I break 12 into? What perfect square? 4 and 3. The 4 comes out and it becomes a 2. So I get 2 root 3. Done. You have to be able to do these easily because this is just an assumption of what we assume you know. Root 32, what can I break it down into? The biggest perfect square. 16 and 2. 16 comes out, it becomes a 4. So I get 4 root 2. 75, what on that chart can I break it down into? What's the biggest one? 25 and 3. I always list my perfect square first. You don't have to, but I find it's easier. And then the 25 comes out and it becomes a 5. 90. What can I break it down into? 9 and 10. When I take the 9 out, it becomes a 3. 3 square root 10. Okay, cubics. What in the cubic column can I break 16 down into? 2 and 8. So I'm going to go 8 and 2. And the reason why I use from the cubic column, so I'm going to either look at the 1, the 8, 27, the 64, the 125. Because when I take them out, I get the front number, right? So when I take a cube root of 8 out, what do I actually get? 2. So it's 2 cube root of 2. Now 250, what of the cube root column on the board could I break 250 down into? 125 and 2. What's the cube root of 125?
5.
5, because it has 5 beside it. So I'm going to get 5 cube root of 2. Now we did this last year. It's not used nearly as often as the reducing, but I want to go back over it just so you remember it, and just in case they ask it as a weird answer, but most of the time we reduce. So we do what we just did. We reduce them. But they could ask us to make it an entire radical, put the whole entire thing underneath. It's very rare this happens. Do you remember how you do it?
2 squared.
Yeah. So if I took it out of here by squaring it, square rooting it, I'm going to put it back in by squaring it. If I took these ones, E and F, out by cube rooting them, I'm going to put them back in by cubing them. You do the opposite, right? So how do I get this back underneath? Well, I go 2, you just raise it to whatever the index is. The index is a 2 this time. 2 squared times 5. So what's it going to be? 40. Try again.
That's
20. Then this one, the index is 2, so I have to square it to put it back underneath. So I go 13 squared times 2, which is 338. C and D, try them out. So this one you're going to bring in as 5 squared times 2, which is 50. Square root of 50. This one you're going to have to cube it, right? 4 cubed times 2, which is 120. Now don't forget, both of these need to have little cube root symbols. If you don't keep the cube root symbol, you've actually turned it to a square root, which is totally different. So make sure you have the little 3's as your indexes. Now should we be able to check them? Should we be able to go 4 cube root 2, get a decimal, and then the cube root of 128 and get a decimal? They should match, should they not? They're just different forms of the same thing. And we're going to flip over. So here it says, express each radical as a simplified mixed radical. Write all perfect squares within the radicand first, then remove them. They become coefficients, leaving the non-perfect squares with it. So, 54, what could I break that down into?
6.
Wait, what were we supposed to do? E?
On the last one.
No. So 54x squared, what can we break 54 down into? 6 and 9. So I'm going to go 9 times 6. And then I need to, it's square roots, so I need to break the x's down into 2 x's, because it's a 2 for 1 special, right? So if you want to, you could go x times x, if that makes it easier for you. I'll show you why. So a 9 comes out as a what? A 3. And then 2 x's come out as just an x. Because it's a squared. If it was a cubed, how many x's would I need to take out an x? 3. So what am I left with on the outside? 3x square root 6. You try the next one. That says try. So 54 would still break down into 9 and 6. That didn't change. The x to the 4 we could break down as to x, 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 and I'll show you what I mean. So the 9 would come out as a 3. The 1x would come out as a x, and these two would come out as a x. So every x squared, I technically get 1x out. We agree? For every x squared, I get 1x out. So this would be an x times an x, which is just an x squared. So I get 3x squared times root 6. So instead of splitting them as x's and x's, you just need to split them as x squareds. We agree? So another way I could look at this, I can look at it just like that, and that's perfectly fine. Or I could say 9 times 6 times x squared times x squared. Because an x squared times an x squared is next to the 4, right? Because when you multiply two bases that are the same, you actually add the exponents. So this 9 would come out as a 3, and each of these x squareds would come out as 1x, right? So this would be 1x and another x, so I'd get x squared. Same answer, 3x squared root 6. So whichever way you find easier. 350, what could I break it down into? 25 and what? 14. And then the x cubed I could break down into what? Yeah, you go x squared and an x, right? Because when you have the same base, you add exponents, so that would add to x cubed, right? The 25 comes out as a what? As a 5. And the x squared comes out as a x. What about this x? I can't do anything with it. It's an x to the 1. I can only take out x squareds. We agree? So I'd be left with 5x in front. Square root, what's left over on the inside? 14. And an x to the 1, or just x? You try the try. So we have to break these up. The 350 breaks into 25 times 14. That hasn't changed. The x cubed breaks down to x squared times x1. The y5 breaks down to what? Y squared, y squared, y1. So the 25 comes out as a 5. The x squared comes out as an x. The y squared comes out as a y. The y squared comes out as a y. What's a y times a y? A y squared. And then the rest stays in, right? So on the outside I'm left with 5xy squared. And on the inside I'm left with 14xy. So, these ones here say express each mixed radical as an equivalent entire radical. So you're just taking them from the outside and putting them back in. So all we're doing is squaring if it's an index of 2, or cubing if it's an index of 3. So try these ones out. See how you do. So for this one, we have to bring the 2 in and the x in and square it. So we're going to get 2 squared x squared times 5. So 2 squared is 4 times 5 is 20x squared. This one we're going to get 13 squared x squared times 2, which is 169 times 2, which is 382. I don't remember what it was. We did it up here. 338. X squared. With equal signs in front of these. This one is going to be 5 squared x squared y squared squared times 2, which is 25 times 2, which is 50, x squared y4. This one, you're going to get 9 squared x squared squared y squared times x. So you're going to get 81. X squared squared is x to the 4, and then x plus 1 is x to the 5, y squared. So we're using grade 10 exponent laws. This one's cubed, see if you bring it inside. So you're going to get 4 cubed x cubed times 2, which is 128. This is 64 times 2, which is 128 x cubed. And what can't we forget? The little cube root index. Don't forget the 3's. Yep. Don't forget the cube root index. And then this one we're going to get cube root. So we're going to get 2 cubed x squared cubed times 4. So I'm going to get 8 times 4, which is 32, x to the 6, and don't forget the index, or you are wrong. I'm not worried about task 3. We're going to go to task 4. So task 4 you guys looked at last year. You added and subtracted them. So here it says simplify each expression. In order to add, you need like radicands. So just like you need an x plus an x to add x's, you need x squareds, you can put are like terms. Numbers without variables are like terms. You can put those together. Same thing here with radicals. So if you have one under the radicand is the same, you can put them together. Okay? So here it says we have 7 root 11 minus 3 root 11 plus 8 root 11. I can put these all together because they have root 11s, correct? So it's like I have 7 apples minus 3 apples plus 8 apples. What's that? That's 7 minus 3. Plus 8 is? So I get 12 apples. Apples just happen to be root 11s. The second, the tries. Can I put them all together? No. I have a root 3x and a root 3x. So it's a 1 root 3x and a 4 root 3x. Well, how many root 3x's do I have? Nope. 4 root 3x and 1 root 3x is? What's 4 plus 1, guys? 5 root 3x's. And then I have negative 4 root 2 minus 1 root 2. What's negative 4 minus 1? Negative 5 root 2. So what's under the radicand doesn't change. And you just treat it like they're like terms, just like when you add an x with an x, right? It's the same thing, they're just radicals. So you try B and the try. Try that one and that one. So here I can go 9 root 6 minus 1 root 6. What's 9 minus 1? 8 root 6. And then 12 plus 4 is plus 16. Now that's when I can only put the root 5's together and the root 7y. So 6 root 5 plus 4 root 5 is 10 root 5. Minus 1 root 7y minus 3 root 7y's is how many? Minus how many root 7y's? 4. Okay. Next page. Okay. C. What's our problem? Uh-oh. They don't match. So what are we going to have to do? Reducing radicals from grade 10 for almost every question. Do you know how we reduce radicals from grade 10? That is going to be the first step always, grade 10, before we can even do the grade 11 stuff. So root 20d, what can I take out of there?
4. Yeah.
I can break it down into 4 and 5. And then the d is just a d to the 1, so there's nothing I can do with that, right? And then plus 5, 45 I can break down into what? 9 and 5. And then the d just stays a d. Now, the 4 comes out as a what? A 2. So I'm left with 6 root 5d. And then the 9 comes out as a 3. And then I'm left with 15 root 5d. And all I did so far was grade 10. Correct? The grade 11 stuff's the easy part. It's the putting together like terms. Are they like terms now? Root 5d, root 5d? Yep, so I just do integers. What's 16 plus, or 6 plus 15? 21. You try the try, the d, and the try. Try those ones out. So, 10e. Is there anything I can do with that one? For 10, can I take any perfect squares out of it? Nope. So it's going to say 1 root 10e. Sometimes it's easier if you put a 1 in front of it to visualize what you're supposed to do. 90, what can I break that down into?
10 and 9.
Yeah, 9 times 10 and then an E. The 9 comes out and becomes a 3. Plus 4 root 40. You do 4 times 10 and then E. The 4 comes out and it becomes a 2. What do you do when there's two numbers? Multiply. So we get 1 root 10E minus 3 root 10E plus 8 root 10E.
6 and
Yeah, you get 1 plus 8 is 9 minus 3 is 6 root 10E. And we put them together because they're all root 10E's. What if 2 were root 10E's and the other one wasn't? Could I do anything? I put the 10E's together and the other one would just have to sit. Yeah. Yeah. D. 5 root 3. Can I do anything to that? No. What about root 12?
Yep.
What could I break it down into? 4 times 3. The 4 comes out and it's a 2. 48. 16 and 3. 16 comes out and it's a 4. 75. 25 and 3. The 25 comes out and it's a 5. So I'm going to get 5 root 3 plus 2 root 3 minus 4 root 3 plus 10 root 3. So 5 and 2 is 7. I can put these all together because they're root 3's. 7 minus 4 is 3 plus 10 is 13 root 3. $63 break down into equal sign 9 and 7. Do you see how I have equal signs running down the whole left side? Because this one equals this one equals this one equals that answer. They're all the same answer. Like if you typed this one into your calculator, then this one, then this one, then this one, you get the same decimal the whole time. If you don't get the same decimal the whole time, you messed up. That's how you can check them. So 9 times 7 plus, oh, the 9 comes out, it's a 3. 75 is 25 times 3. 25 comes out and it's a 5. 28 is 4 times 7. 4 comes out and it's a 2. And then 27 is 9 and 3. The 9 comes out and it's a 3. So we get 3 root 7 plus 5 root 3 minus 4 root 7 minus 9 root 3. So 3 minus 4 is negative root 7. Or negative 1 root 7, same thing. And then 5 minus 9 is negative 4 root 3. You can only put the root 3's together and you can only put the root 7's together. We're going to look at the task 6. Can I reduce any of them? 3 root x. Can I take an x out? No, it needs to be an x squared, right? The 4 I can. So the 3 root x stays the same. The 4 root x, the 4 can become out and be a 2. So I get minus 2 root x plus root x. I like writing it as a 1 root x. Now they're the same radical, aren't they? Same radicand? What?
2x.
No, when you take a 4 out, it becomes a 2. The whole 4 comes out as a 2.
Yeah.
So 3 minus 2 is 1 plus 1 is 2 root x. Now what happens when you have a little x sitting under here? X has to be what? Greater than or equal to 0. The moment you have an x just sitting under there, at any point in time, even if you can take the whole thing out, it still has to be greater than or equal to 0. Let's look at the tries. So 9x, I can actually take the 9 out and it becomes a 3. Yeah. So we get 3 root x. And then the x cubed breaks down into an x squared times x to the 1. And the x squared comes out as a x. Minus 4 root x stays. Minus x root 9x The 9 can come out as a 3. So we're left with 3 root x plus x root x minus 4 root x minus, now the x in the 3 is not cubed, it's x times 3, so I get 3x root x. Now what happens? You still can collect like terms, so you're still going to get a root x, but you can only collect the numbers that are actually numbers and variables with variables, right? So we're going to get a root x because they all are root x's. But we go 3 plus x is 3 plus x, minus 4 minus 3x. We can put the numbers together that are together. So 3 minus 4 is negative 1. X minus 3x is minus 2x, sitting in front. It's kind of ugly. You do the B, the try, the C, the try, the D, the try. Try those ones out. This should be in brackets because it's sitting in front of here. If not, it just looks like the negative 2 is in front. So that needs to be in brackets. And then x has to be greater than or equal to 0. So we're going to go and break up x to the 5 as x squared, x1. Or you could say x4, I can take 2 out. I don't care how you do it as long as you get the answer right. If you're like, 7, no, bad news. Boom, boom, take an x for an x, and I get an x squared. So I have x squared root x. And then this one, I have 3x squared root x. And those are the same term. X squared plus 3x squared is 4x squared. Good answer. So good. Everyone don't answer at once. X has to be greater than or equal to 0. That's not a J, it's a semicolon. Do not ask me. All right. Good times.
Is it a J or a semicolon?
Oh, who are you? You're supposed to be my good one. Another orange. The verge of rotting. That's where we're at. No excuse. All right. So here we have root 16 comes out as a 4. And then the x4 comes out as a x squared. So we are going to get a lot of blue in one area. It's just disastrous. Okay. So we have 4x squared root y plus 3x squared root y. 4x squared plus 3x squared is 7x squared root y. And then I had an x underneath and a y. So we could say x comma y have to be greater than or equal to z. Okay, cube roots. Cube root of 56. What can I break it down into? 27 and 2? That's not true. Yes, it is. 4 and 7. That's not helpful. 4 and 7. That's 28.
I just skipped the steps. Sorry.
8. 8 and 7. There we go. Oh. The 8 came out as a 2. Yes.
Yeah.
I see you now.
You see it.
I see where you're at. 8 times 7. 8 comes out and becomes a dose. So we get 2 cube root of 7. Want to know what people do the worst of this? They completely drop the cube off. They're like, I don't know why that 3's there, so I'm just not going to write it. Not a good decision. It is not a square root. You can't be like, meh, don't like it that way. I'm changing it. It doesn't work. Okay? Then we have this cube root. So the 8 comes out as a 2. I'm going to write it like this. 8, x to the 3, x to the 2, y to the 1. Why did I write it as an x to the 3 this time? It's cubed, so the only way I can take a cubed out is if what? Bergen?
You have 3.
You have 3 of them. It's like a 3 for 1 special instead of a 2 for 1 special now. So the 8 comes out as a 2, and the x cubed comes out as a 1x. And then the rest I don't have 3 of, so I can't take them out. So I'm going to get 2x cube root x squared y. And when it's a cubed, I don't need any restrictions. Because I could take square roots of negatives, or cube roots of negatives, and cube roots of positives. So when it's a cube root, you should actually throw a little party. Because you don't have to put restrictions. Yeah. Okay, this one, cube root of 5 is as low as it can go. 625 breaks down into cube root of 125 times 5. Thanks for answering. 125 comes out as a 5. There, we got some answers. So to get the cube root of 5, which is actually just 1 cube root 5, minus 5 cube root 5. I don't know why I wrote the 5 so small. 5 cube root 5. 1 cube root 5 minus 5 cube root 5 is negative 4 cube root 5. And then these ones have to break down. So the cube root of x cubed. What's the cube root of x cubed?
No.
It's just x. The whole thing comes out. Cube root of x cubed is an x. No cube root sign anymore. Plus 4 cube root x, nothing I can do with that. Then I get minus, what's the cube root of 27? 3. And it's going to be 3 times, so it's 3x. And then 64 comes out as a 4. So I get minus 4 cube root x. Now I can only put the cube root x's together, and then I can put the x's together, so I can't put them all together, because they're not the same. So x minus 3x, 1x minus 3x's is 2x's. And then 4 cube root x minus 4 cube root x, 5. You just cancel. 0 cube root x's, which is no cube root x's.
Wait, so why do the cube roots cancel?
Because it's 4 minus 4.
Yeah,
4
it's
and
like
4 is
2x
0.
minus 2x. You understand?
Yes.
Okay. Sometimes look angry, so I don't know if you understand. Or I'm just like, I don't know, and then you smile after, and then we were okay. But I'm like, I'm not quite sure. I'm like, I don't know.
That's a bit of a fault. Why?
It just happens. I feel, yeah. I'm there sometimes too, except I'm actually angry when I look angry. So you're in a much better boat. Yeah, the happy angry. I'm just angry. It's a scary place. It's like angry squared. Don't want to go there, peeps. Okay, 278 is the page. It's if you slip ahead or flip ahead a page, you'll see it. And if you're complaining, I'm not going to change this. I'm going to go for it. There's lots of questions. Enjoy your life.
You know
Except
what?
I'm not.
Traffic's so cheap today.
Yes, well played. Well played. Okay.
So fun.
Eight, I want you to do AB. 9, I want you to do AB. 10, when in Rome, AB. Oh, 11, 14, 15, there's more. 26, 30, 31 and a half, 42. You weren't suspicious when I put 31 and a half? Have you ever seen one of those?
Well, I just figured you do half.
These don't exist. This is
Oh, I
just
was
me.
writing those down.
It's just me being funny.
Bro! That is
Bro!
I was writing.
Bro, why would you do that to me, bro?
She wants us to just do 8.
30. Did you write 31 and a half? Actually, did someone get
I was
there?
getting there. I was at like 31.
Girl, please.
Wait.
Girl,
I was getting
please.
just like half the question. Like, I
You
was
do
like,
those questions.